Hello first year, welcome back. Today we're going to finish our discussion about conductors and insulators and move on to convection and radiation. Page 12 here gives us a summary of conductors and insulators, where we can see that in general all metals are good at conducting heat and non-metals are poor conductors. Where do we use these? And there's some examples here. At home, if you have a pot, you will notice the pot is made with a plastic handle so the heat doesn't come through to your hand. Radiators are made of metal so the heat can be conducted from inside to the air outside. In your house, there's lots of places where the heat may escape, such as the chimney, out the windows, out under doors, through the roof and walls. Many things are done to prevent this. Okay, in your roof you may have some loft insulation to trap air between the ceiling and where the radiators are, or you may have the walls insulated, or you may have double glazing. There are many methods can be used to stop heat from leaving the home. The new topic we're going to look at today is called convection through liquids. Now obviously in class we would have carried out this experiment, but in Firefly I've posted a video of the similar experiment for you to watch to give you an idea of what would happen. We have water with a chemical inside the water and a flame just below. When heated, this little purple chemical starts to expand and it moves through the water in a particular way. Okay, it will move round, leaving a purple trail as it goes. When the water at the bottom of the beaker is heated, it expands. This hot water is less dense than the surrounding cold water, so it rises up to the surface and the water drops that are cold take its place. So it starts to rotate round. This movement of rotating is what we call a convection current. This method of heat transfer by particles flowing is called convection. Okay, so in liquids we have this movement of particles. The heat causes them to rise, and as they cool they begin to drop. Convection also occurs in a gas. Again, an experiment we unfortunately aren't able to do, but there will be a video on the Firefly page. If you have a candle, what happens is it heats up the air in the chamber. The air then rises out of the chimney. The smoke that comes from the smouldering taper would be drawn down and in and follow the heat, creating a sort of channel of air that moves from the input to the chimney. This again is caused by convection. Colder air is pulled down the chimney to replace the hot air. How do we use convection at home? We have radiators. They heat the air in the room. The hot air in the room circulates and rises, making the temperature of the room increase. It also ventilates a room as it draws in cold air from the outside, which could be through a window or under the door. In a kettle, water is heated. What the heater does is it encourages the water to rise in temperature and it starts to bubble at the top. When it is bubbling, you would know, for example, the kettle is boiled. A hot air balloon is able to fly into the sky and rise above the air because of the gas inside the balloon is being heated as well by the flame. Miners who dig for coal would light a small fire at the bottom of the mine shaft. Why would they do this? This is because the heat would rise up the mine shaft, keeping them warm as they work. Here we have an example of hot water in your house for you to have a look over. The boiler heats the water, the hot water rises and enters the pipe, and then it circulates round all of the radiators in the house. Here's your boiler, and you can see the radiators heating each room. Convection happens in nature. If you think about the beach where you have the sea and the land, during the day the land gets warmer than the sea, the air above the land gets warmer than the air above the sea. This warm air rises. This gives us a sea breeze. During the night, land cools more quickly than the sea, then the air above the sea is warmer than the land, and it also rises, and this gives us a land breeze. We have an example of thermals, which what gliders and birds use to soar high in the sky, floating on huge currents of rising hot air. Convection and rainfall, and convection through oceans. The trade winds which blow towards the equator from the north and south are huge convection currents, and these will bring different weather systems across Scotland. Okay, so I will post a few videos for the experiments we've looked at and a worksheet for you to try. In summary, convection is when liquids and gases are heated and are caused to move in a sort of current where they rise and fall as their temperature increases and decreases. Thanks for listening.